Welcome back, everybody, for another deep dive. Today, we're going to kind of look at this question of what happens when AI models.
Okay.
And specifically, we're looking at large language models like ChatGPT when they're trained on content that is generated by other AI.
Right.
It's kind of an AI echo chamber, if you will.
Yeah.
And, the question is, could this actually lead to AI losing touch with reality?
Interesting.
Right?
Yeah.
So we're looking at a research paper called The Curse of Recursion. Training on generated data makes models forget.
Okay.
And it has some pretty interesting and maybe unsettling findings.
Gotcha.
So,
Well, one of the things that they introduce in the paper is this idea of model collapse.
okay.
And essentially what that is like it's a degradation of a model's accuracy and like fidelity over generations when it's trained on synthetic data primarily.
Okay.
And they actually observe two forms of this collapse. They have like an early and a late stage.
Right.
Early stage, kind of think of it like making a photocopy of a photocopy. And so initially the degradation might be subtle, but with each copy you make the image, it loses its clarity.
Right.
And so similarly, AI models start forgetting kind of less common occurrences and kind of skewing their understanding towards more frequent patterns that they see in this like generated data.
So essentially, it's becoming less diverse.
Right.
And its outputs, it's focusing on just a narrower range of possibilities.
Yeah, exactly.
Okay, so what about what happens in the late stage of model collapse?
In the late stage, it gets really bad. The model's grasp on the original data distribution is like so distorted that its output like barely resembles real-world data. So think of the photocopy analogy again. Eventually, you wouldn't even recognize the original image in the final copy.
Yeah, you just have a big mess of
Exactly.
gray or something.
Exactly. And so they identify kind of two main causes for this. Statistical and functional approximation errors.
Okay, so break down those errors for us.
Sure. So statistical error comes from using like a finite data sample to represent a potentially infinite distribution.
Okay.
So like imagine trying to understand the global climate based solely on weather patterns in a single city.
Yeah, your understanding would be quite limited.
Yeah, exactly.
Potentially misleading even.
Exactly. And this problem is amplified when you're training on synthetic data.
Right, because it's already removed from the original source.
Exactly.
So it's like building a house on a foundation that's a little bit off kilter.
Exactly.
Okay, now how about functional approximation error?
So functional approximation error, this stems from the inherent limitations of the AI model itself.
Okay.
So even with perfect data, a model might just lack the capacity to fully grasp the nuances of the real world.
Okay.
And so they illustrate this using like a single-dimensional Gaussian distribution example.
Okay.
And so as the model is trained on synthetic data errors compound, and this leads to a drift in the model's parameters and outputs that diverge further and further from reality.
So it's like a game of telephone where the message gets increasingly distorted with each retelling.
Exactly. Yeah.
Okay, so if AI keeps training on AI-generated content, could it lose its grip on human language altogether?
Potentially. And that's kind of what they try to explore through different model types.
Okay.
And so they start by evaluating what are called Gaussian mixture models, or GMMs.
Okay.
And variational autoencoders, or VAEs.
Okay, could you give us like a really quick rundown of how those work in this context?
Yeah, so essentially GMMs represent complex data sets as combinations of simpler Gaussian distributions.
Okay.
So essentially you're grouping data points based on their similarities.
Okay.
VAEs, on the other hand, work by like encoding data into a lower dimensional space and then decoding it back.
Gotcha.
So it's similar to like compressing and decompressing a file.
Gotcha. So they're using these models as kind of simplified test cases to study model collapse.
Right, exactly.
So what did their evaluations reveal?
So the findings were really striking. Even with these relatively simple models, they showed clear evidence of model collapse.
Wow.
So for instance, they trained a VAE to generate images of handwritten digits.
Okay.
And as the model was fed with more of its own generated data, the images, they devolved into this blurry mess.
Oh, wow.
They lost all the distinctive features of the original digits.
So that's a pretty powerful visual indicator of the problem.
Exactly.
Yeah.
And this degradation, they visualize it in the paper, and it really clearly demonstrates the potential for models to drift from reality when trained on synthetic data.
It's like watching those photocopied images degrade with each generation.
Exactly.
Until they're unrecognizable.
Exactly.
Okay, so GMMs and VAEs are helpful for illustrating the concept.
Right.
But the real concern lies with large language models.
Yes, definitely.
LLMs, which are far more complex.
Yeah.
And they drive much of what we see in AI today.
Exactly.
So this is where things get even more interesting, because LLMs are the engines behind so much of the current AI landscape.
Right.
So understanding how model collapse affects them is crucial.
Absolutely. And the paper digs into that.
Yeah.
And they acknowledge the challenges of studying LLMs in particular, like the sheer computational resources.
Right.
And like the environmental cost of training them from scratch.
Yeah. Imagine the carbon footprint of training something like GPT-3 multiple times over.
Exactly. Yeah, it's massive.
Yeah, the energy demands of these models are significant.
Yeah.
So how did the researchers approach studying model collapse in LLMs?
So they opted for a more pragmatic approach. They decided to sequentially fine-tune a pre-trained language model with AI-generated data. So this allows them to kind of simulate the effects of multiple generations of LLMs training on each other without the resource-intensive process of training from scratch every time.
So they're building on an existing LLM, and then they're feeding it synthetic data generated by itself.
Exactly.
Creating a chain of models, each learning from its predecessor.
Exactly.
Okay, so what happened as they did this?
So what they found was that even with this fine-tuning, the model's performance still degraded over time.
Wow.
As it was fed with more and more synthetic data.
Okay.
And they measured this using what's called perplexity, which is a metric that reflects how well the model can predict the next word in a sequence.
So higher perplexity means the model is getting worse at predicting language.
Exactly. It's like if you're trying to guess the ending to a familiar story,
right,
the better you know the story, the lower your perplexity would be.
Makes sense.
Right.
Okay.
And so they saw this like steady increase in perplexity as the model was trained on more AI-generated data.
So it's becoming less accurate and more likely to produce kind of nonsensical or unexpected outputs.
Yeah. And they also found that the model started generating more sequences that the original model, the one trained on like genuine human data, considered highly improbable.
So it's like the model is losing its grasp on the nuances of human language and kind of veering off into this uncharted territory.
Exactly. That's a good way to put it.
Okay.
It's important to note, though, that they go beyond just like illustrating this model collapse.
Okay.
They also investigate some potential ways to like mitigate it.
Okay, interesting.
And so one of the things they explored was the impact of repetition in the generated data.
Yeah, I've definitely seen that before, where it's like the model gets stuck in a loop.
Yeah, exactly.
And just repeats the same phrases over and over again.
Exactly. And so they noticed that like the language models in their experiments were producing a lot of these repeating phrases, which is a pretty common issue with AI-generated text.
Right.
So they tried to like penalize the model for generating these repeating sequences and essentially like discouraging it from repeating itself.
So did that work?
Actually, no, it kind of backfired.
Oh, wow.
That intervention actually made the model's performance worse.
Really?
Yeah.
That's surprising. Why would preventing repetition make it worse?
So it seems like by forcing the model to avoid repetition, they inadvertently pushed it to generate like less probable and more nonsensical language.
So it's like a delicate balance.
Yeah.
You want to discourage the mindless repetition.
Right.
But then forcing it to be overly original can backfire.
Exactly. And this kind of highlights a key challenge in AI development, right? Like we need to figure out how to guide the model's learning process without stifling its ability to like generate diverse and creative outputs.
Right. You don't want to constrain it too much.
Exactly. And so the paper's findings really suggest that like simply throwing more data at the problem isn't the solution.
Right.
It's really the quality and the source of the data that matters.
It's not just quantity, it's quality.
Exactly.
Okay, so we've seen how model collapse can affect various types of models.
Right.
From the simpler GMMs and VAEs to the more complex LLMs.
Yeah.
What does this all mean for the future of AI, especially as AI-generated content is becoming more prevalent online?
That's the million-dollar question, isn't it?
Yeah.
And the paper itself doesn't really provide any easy answers.
Of course not.
But it does underscore this critical need for access to original human-generated data.
Yeah.
Like, as AI-generated content proliferates, we need to be able to distinguish it from the real deal.
Right.
And kind of protect the integrity of the data sets that we use to train future AI models.
So it's like we need to develop a digital immune system for AI.
That's a great analogy.
Some way to recognize and filter out this potentially harmful data that could lead to model collapse.
Exactly, and it highlights the need for innovative approaches to AI development.
Right, we can't just assume that more data equals better performance.
Exactly.
We need to be thoughtful about where that data is coming from and the potential biases that it might introduce.
Exactly.
Now, while this research paper focused on the technical aspects of model collapse, there are some broader implications to consider as well.
Absolutely.
I mean, imagine the potential consequences if model collapse starts happening in AI systems that are being used for, like, critical tasks, like medical diagnosis or financial forecasting.
Yeah, the stakes are really high.
Yeah, it's a bit of a sobering thought.
It is.
So what can we do to prevent model collapse
and
ensure that AI remains a force for good in the world?
Yeah, so the paper doesn't offer any quick fixes, but it does point towards some promising avenues for research. One is to invest in developing methods for detecting and filtering AI-generated content. Another is to really prioritize creating and preserving large, high-quality data sets of human-generated data.
So it's like building a digital Noah's Ark to safeguard the seeds of human language and creativity against this potential flood of AI-generated content.
So that's a great analogy.
What are some of the challenges we might face in pursuing these solutions?
Well, I think one of the biggest challenges is just the sheer scale of the internet. And like the speed at which this AI-generated content is being created.
Yeah, it's like trying to find a needle in a haystack.
Exactly. And the haystack is growing exponentially.
Yeah, constantly.
And another challenge is that AI itself is constantly evolving. So as these AI models become more sophisticated, it's going to be even harder to distinguish their output from human-generated content.
Yeah, it's like a moving target.
It is, yeah.
We're in a race against the machines.
In a way, yeah.
Trying to stay ahead of them.
But it's not a race that we can afford to lose.
Definitely not.
And the paper highlights, this increasing value of data that really captures genuine human interactions. Like, that type of data is going to become even more crucial as a benchmark for training and evaluating AI models.
So it's almost like we need to create a digital library of Alexandria. This vast repository of human knowledge and creativity to kind of preserve the authenticity of our data. And make sure that AI stays grounded in that human experience.
Exactly. And that raises a whole other host of ethical and logistical questions.
Like who owns that data?
Exactly. Like how do we collect it?
How do we curate it responsibly?
Who controls access to it?
Yeah, these are all really complex issues that we need to start addressing now as a society.
Yeah, it's not just a technical problem.
It's a societal one.
Exactly.
That requires a multifaceted approach.
Absolutely.
Well, this has been a very thought-provoking deep dive.
It has.
I mean, this idea of model collapse and the potential consequences, it's both fascinating and concerning.
It is. And the conversation certainly doesn't end here.
No, it doesn't.
As AI continues to evolve, we need to remain vigilant and really engaged in shaping its development.
Absolutely. I encourage everyone listening to go check out the paper, The Curse of Recursion.
Yeah, it's a great read.
Delve deeper into this really important topic.
Yeah.
And as always, keep exploring, keep questioning, and keep learning.
Exactly.
We'll see you on the next deep dive.